Sir, come this side. No, no. Sir, you sit. Please. Sir. Yes, sir.
Now to invite the head of the Department of Chemistry, Dr. O. Sailaja ma'am, onto the dais. Now I extend a warm welcome to invite the head of the Department of Physics and Electronics, Uday Kumar sir, onto the dais. Light is the symbol of knowledge, and knowledge is the path to progress. As we embark on this enlightening journey, education that signifies with knowledge and pursuit of excellence.
President's opening remarks.
Request Professor B.L.B. Prasad, Director, Center for Nano and Soft Matter Sciences, and also Professor N. Iswar Prasad, Director, R&D, MJIT, Professor, Department of Metallurgical and Material Engineering, and our Dr. B. Nara Garu, and our Dynamic Secretary and Correspondent, Dr. T. Srinivas Garu, and heads of the departments, Physics, Chemistry and Electronics, and my dear students, a very good morning to one and all. To release the schedule of this program, and first of all, I also like to thank actually states Dr. O. And explain
very
Thank you, sir. Now I invite Dr. K.B.N, sir, to present the theme of the seminar.
Let's use creativity. Creativity is thinking for knowledge and knowledge makes you great. By Abdul Kalam. Good morning, everyone. This is Dr. Kumar, Department of Physics and Electronics at this conference. It is my privilege to welcome you all to this today international conference on functional and smart materials organized by K.B.N College at Thomas Vijayawada, jointly in collaboration with the Andhra Pradesh State Council of Higher Education. I extend my warmest greetings to our eminent scientists, physicians, industry experts, special guest faculty members, and researchers and students who have gathered here today to share their invaluable knowledge, innovative ideas, groundbreaking research on this highly relevant topic. I also extend my sincere regards to Dr. Srinivasam, Secretary at College, whose constant engagement and support have made this event. A special thanks and welcome to Dr. V. Narayan Rao Garu, Administrative Officer Institution, encouragement in this conference. It is my great honor to our esteemed principal, Dr. V. Krishna Garu, whose leadership and vision have played a crucial role in promoting excellence in our institution. I also am grateful to our respected principals, Sri P. Ramesh Garu, Dr. V. Venkateswara Garu, and Dr. K. Ramakrishna Garu, who have always supported in academic-oriented individuals. A special thanks to Dr. K.B.N. Garu, Organizing Secretary of this conference, for his tireless in bringing this event to implement, and to all our faculty members, research scholars, students, and participants. I extend a warm welcome. I warmly welcome to our esteemed Chief Guest, Professor Sadgar from for Nano and Soft Matter Science, Bangalore. Sir, your presence is a privilege, and we have valuable time and insights. Mr. Prasad Garu, R&D, Mahatma Gandhi Society, Hyderabad. Welcome. Asia. Department of History. of technology. Aerospace and improve efficiency. And perpetuate the new engage of this academic to get research driven scientific. Much and thank you and
The others to lead the conference proceedings. I request Vice Changes to Secretary Professor to speak few words on this occasion.
Members of K.B.N. I was joking with Dr. How many number of times I have visited K.B.N. I really students get benefited. And I also, on this occasion, on record, apologize to Dr. Krishnaveni, because I kept on saying that you okay, and I think she has followed that. I think we are even running ahead of the schedule, not behind the schedule. Really congratulations to you, madam, and then sorry for so many times repeating that. Okay, the main reason is that part of the state, you see more emphasis on other things than that's the reason why etc. Speaking to us, we should not be taking more time on inaugurations and then speeches and then presentation. I congratulate and then compliment all the faculty members, the secretary, members of K.B.N. College and the SKP Individual School Society. Great events regularly and then ensure that the students get benefited. I hope the reason whatever the reason why we came, the purpose of this conference is only when you start interacting, and you know then you be prepared. I will be there when I am talking to clients. I will not be here, okay? And I will start asking questions. If you don't ask me questions, I will ask you questions. You be prepared, okay? So you decide. Okay, so congratulations once again, and then the best wishes to you all for a wonderful 2 days program. Take the full day of this program, and the purpose of such conferences, as I mentioned earlier, is that if someone by choice take up science as a career, I strongly believe that whatever the travels and the time we spend in preparing these talks, etc., are kind of fulfilled. Congratulations to all the members who have participated, and sincere thanks to all the organizing committee for having us here. Have a good day.
I'd like to thank K.B.N. We know it as a K.B. Now it's called K.B. College. So, Bhaskar Narayana is always a Bhaskar, and I mean, Bhava is totally different from Narayana. Bhava Narayana is so, in this college for a long time when we were students. You know? I was telling Ravi, we used to and then come Vijayawada, a traditional center for central Andhra Pradesh. Vijayawada events. That's the only theater where you have so these are all some unique features of Vijayawada, and although you know much more than all this, so Vijayawada is always. I also took my JEE exam in Daya College. So Vijayawada is a fond of many memories for me. I hail from Ellore, from CRD College. So the sciences in Andhra Pradesh were totally what you call dominated by Vizag. If I were to say, the University College of Vizag was very famous. Later, each and every college of Andhra Pradesh science. Many people do not know the University College of Andhra became the first students of IISc Bangalore, which is ranked in the first 100 of the world universities. So that is the kind of penetration that Andhra Pradesh students have in basic sciences. And the basic science also extremely important because The Nobel Prizes are not given for engineering and technology and systems. They are given for the basic sciences. Okay. In fact, when I was there in Stuttgart as a Humboldt fellow, the next building used to house 3 Nobel laureates. They travel different places to come and meet them. So someone said that the professor will be meet. I said, no way. I'm a engineer. I respect engineering much more than science. But my science has been a top priority in many countries. Unfortunately, in India, we say something else. Okay? And what we say, but this situation has to change. They should believe what they should believe, and what they think they should believe. Don't try to do it in the next day or there. You have to dream very big and then keep on dreaming about them, and then you materialize or realize it in your lifetime. Dream today should not. We dreamt a developed India, and the developed India doesn't come that easy. You have to work for it. And I was mentioning if you look at this biodata, you will say that very few the official directors, we all are retired directors. Okay? But he's a person very few people have this amount of experience is got in the frontline technology in Europe. So please look at those people as an inspiration and then try to become. I will be happy if after 12 years we find one of you go and do a frontline international research and say bring name and fame to this K.B.N. college. So I would like to come. I also had a senior Vijayawada is now becoming internationally acclaimed. The Chief Minister has a lot of aspiration for this state. And then I am telling you, every Andhra, Telugu people, they don't take out their money. But they have lots of money. If they take out their money and invest in Vijayawada elsewhere, the state has fantastic potential to come up as the #1 state in the country. We have resources and because underdeveloped industry, we don't have finance, we don't have big business. All the 3 are the ones which will spend money for India. And in turn they go to 5 trillion, forget about 3 trillion, 5 trillion. This money in the pocket should come out. When they come out, Andhra will be the #1 because we have a lot of money in the pocket. We don't take it. Only for fear, let me tell you, Indians do not take out money for fear of losing. We have nothing to lose. World is craving for the mobile money or the money which is. So if you don't take out and invest wisely into our human resources, advanced technologies, we are not able to replace the imports. Let me tell you. Imports have to be replaced first. Our dollar which we earn very dearly should not go out of the country. So there are several technologies. Myself and Prasad will talk about it, and we have a fantastic 8 more eminent speakers, 5 from America, 3 more from India. I don't think anybody else is able to come to even for the Indian parties. In fact, I would like to see entire best of most of Andhra listen to all these people. It's a great opportunity. And to make an effort to record teachers and then deliver, release it to the YouTube. So I will see definitely the YouTube all the lectures. Promise that next 2 days I'll spend on it. Let me. When India embarked on what we call text, okay, yes, I interviewed the director who's Indian government, which is a technology mission. Russian director is supposed to reimburse various sports, various research institutes, and spend in 1 to 300 crores. Only to take this 2 to 3 lakh crores to 5 lakh crores in Indian textiles. And I'm technical textiles. 3,000 crores. Look at the 3,000 crores what we get from ordnance factories. All are the prototype for the to achieve. Nobody can achieve. India doesn't have nylon. Many people think that nylon is a very simple nylon. Not the advanced UV resistant nylon 66. You know the market for nylon 66 is only 3 times produced. So monopoly. So the students and the faculty and the technologists and the industry, all 4 of them are to work in tandem to realize all these technologies so that we don't spend dollars. Very difficult to get dollars now. If the dollars are supposed to shoot up, let us increase our Indian money resources. And I wish all of you wonderful time. I really mesmerized by Narendra sir's energy. You know, many people say, Ishwar, your energy is difficult to match. Yes, not matched. Yes, superseded. Very fantastic speech. See us, very sincere correspondence university amongst you. And this man was telling me, the students come here with the raw material. I also came to the raw material. And we all pictured as the top level products. I'm sure many of you will become top physicists, chemists, electronics engineer, and electronic science is very important. And physics are the basics. My topic cover all physics and electronics. So listen to all these talks. All of you should note down, ask questions. Leave it on the online. To us on the email. Definitely writing to me to understand more of this. And I wish all of you, especially the top 5 of the college, the top 5 of the nation, then our college is the best in the world. Thank you and all the best.
So it's time to felicitate today's guests. I request Professor K.B.N. Prasad sir. R&D cell.
And all. As a organization of this event conference, it is indeed a great honor to thanks stages 2 days international conference on functional and smart material. First, before I extend my heartfelt gratitude to our secretary and correspondent, Dr. Srinivasu sir, for unwavering support and encouragement in organizing this conference. A special thanks to our beloved Madam, Dr. G. K.B.N. Madam, guiding us with their invaluable insight and leadership. I extend my sincere appreciation to our and Vice Principal Sri B.L. Ramesh Garu, Dr. M.V.R. Garu, Dr. K. Ramakrishna Garu, for their and coordination in this grand success. Heartfelt thanks to our Chief Guest of the day and keynote speaker, Prasad Garu, Director of the Center of the Nano Science and Soft Matters, whose inspiring words and gracious presence have truly encouraged this conference. Thank you for attending this today national conference. My deepest and deep gratitude to Professor N. Ishwar Prasad Garu, Director R&D, and Professor M.E. Hyderabad, to share expertise and reach, providing us with invaluable insight into function and smart material. I also thank Shami Madam and coordinator for their constant support. A special mention to the convener of this conference, Dr. V. Ravi Kumar, whose tireless efforts and dedication have ensured the execution. I extend sincere thanks to the physics, chemistry, along with the other participation and valuable contribution. A special appreciation to our librarian, Mr. Raju sir, for facilitating the access and support for academic endeavors. To my dear friends, thank you for enthusiasm in participation, your engagement that has added a great valuable to this conference. I would also like to extend my appreciation to our Executive Officer Srinivasarao Garu and all the non-teaching staff who's behind the screen plays a crucial role in ensuring the functioning of this event. Last but certainly not least, I sincere thank to from the print and electronic media for covering this conference and helping us share the knowledge achievements with the wider audience. I thank each and everyone who you for being part of the successful conference. Your presence and contribution made this event truly. Thank you.
Now we'll have a keynote original. Like to introduce the resource person, Professor B.L.B. Prasad sir, to the gathering.
Sciences, Bangalore. He also holds a position of a chief scientist in physical chemistry language in India. He had in Hyderabad Central University, from where he obtained a Master of Science. After 2 postdoctorals, one at the Tokyo Institute published close to 140 papers international and has international papers to his credits. As a visiting professor by different universities in countries, including Japan, USA, UK, France, and Germany. He has a PhD under his supervision, and other 6 are pursuing PhD currently. And some of the patients materials and government lecture from Vidyasagar University, West Bengal, and Sianong National Prize for the Chemical Research by CRSI, and the Young Career Award DST Nano Mission 2013, and Chemical Research Society of India Bronze Medal in 2013, and Material These are some of the awards her has got. We are very, very glad. Thank you, everyone. Thank you.
Okay, hold it for me.
Just
Yeah, sure.
10 copies.
Okay, sure.
Shall I keep it? Must you take this one?
Yeah. Don't worry. No problem. Don't worry. I have seen many places. Experience. మధ్య మధ్యలో తాగుతుంటారండి డోంట్ వరీ ఇది పెట్టేసేయండి చేశారా వాటర్ పెట్టుకున్నాను ఎక్కడో అది ఉంది యా షూర్ డోంట్ వరీ ఓపెన్ చేశారా ఇది చూడండి బిఎల్బిపి సరే ఎక్కడైనా యూఎస్బి డ్రైవ్ కనెక్ట్ చేయండి. ఇది పాయింటర్కి. నాకు వెళ్ళేటప్పుడు బుక్ చేయండి, ఇవన్నీ తీసుకెళ్ళాలి. ఓకే, గుడ్ మార్నింగ్. తెలీదా? ఓకే. See, this is what my nature is, right? I will come to you and I will ask you questions. And like, as much as possible, is talking, I will probably target them more. Okay, so be prepared. And once again, thanks opportunity to come here again, talk to you. What I am going to do today, because I am giving a keynote lecture, how to carry out research, right? And many a times, please be prepared whenever you are trying to do research. Sometimes it doesn't lead to that place, right? Then you have to be prepared to take chances. I think Dr. Ishwar Prasad, he was mentioning, like, we are basically risk averse, right? We need to take risks. Research is nothing but to take risks. Be prepared to take risk, do something, and sometimes you do get what you want to get, but sometimes you may not get what you want to get, but then you have to look for opportunities, right? So that's what I'm going to kind of highlight today. And this is a little more research intensive. Generally I give more of introduction, but because this is an this technique called the Feynman technique talks about nanoscience and technology. Nobody would be unfamiliar with Dr. Richard Feynman, who is a Nobel laureate by himself and who is actually credited to have the advantages and other things of nanoscience and technology. 19 this technique is basically analogies, right? I will take daily life with respect to nanoscience and technology. Okay, this is what we do in our group, basically mostly based on nanomaterials. If you look at it, right, many places you will see nano, right? Okay, so what is nano? What do we know about nano? Or my next question is, which nano are we talking about? Okay, which nano are we talking about? When I am saying nanoscience and technology, are we talking about nano car? Are we talking about, there is something called nano edge here, okay? Or are we talking about nano sim here? Nano sim? Be bold, like, why are you worried? Neeku evaru mark ivvatledu kada? Nano simma, nano kara, nano edge. Nano materials. Okay, so none of this is the answer. None of the above. Nano sim. Okay. Hey, son. Sir. మీరు నాకు అడ్డం వచ్చేసేటండి, నేను మీకు అడ్డం రావాలి కానీ ఉంటాను. One of the interesting things is none of the above is the correct answer, right? We are not talking. All of these nanos have some relation to nanoscience and technology that we are talking about. And some of you said that nano sim, right? So you thought that nano sim has some nanotechnology. And actually every material that is used in all of these three different gadgets have some or the other nanoscience and technology, but nothing is bigger cheating than nano sim, right? The reason is that I don't know whether you have noticed the sim size has not changed in all the three things. Okay, this is a normal sim. Unfortunately you are probably not able to see it. This is micro sim, this is nano sim, right? But interesting thing is sim size has not changed. ఏంటంటే ఆ ఎక్స్ట్రా ప్లాస్టిక్ తీసి కట్ చేశాడు అంతే. ఓకే, you want to buy the nano sim, right? What is that? Extra plastic has been removed. And I tell you, please buy or take the normal SIM free, right? Don't buy nano SIM for 150 rupees. Take the normal SIM, cut out, మామూలు కత్తెర తీసుకుని శుభ్రంగా పనిచేస్తుంది. Don't go for this, but I tell you something about nano here. 3 gadgets that is coming to you. These 3 gadgets and the word nano is coming to you. What does it mean here? Nano means small. Very good. Wonderful answer, right? Nano means something else is also coming. Why is that? We all, no, even I would like to have a nano SIM. Why is that? There is some pride associated. Superior, right? Though it is same, we feel superior. Nano, I have a nano SIM, right? That is one thing. 2 things that are coming out of this slide. One is that nano means small. The other thing is nano is special or unique, superior, right? Please remember this, right? Now I go to the other topic, or what we believe in science and technology, right? So as I said, nano means small. Let us remember that. And the other thing is, when we say nanoscience and technology in science, what does it mean? What is nano for science? What does it mean? Sudden anta drop agare? No, I have given here. Tell me what is it? Which one we are talking about? Nanoscience and technology. What does it mean? Because everything is a scale, amma. You will weight is a scale. Right? Okay, not just, this is in English actually it is called ruler, not scale. Okay, so everything is a scale. This is a scale, weight scale, this is a time scale, right? So what is it? Which one of them we are talking about when we are talking about nanoscience and technology? Yeah. Okay, sure. Okay, so answer please. First of all, what does it mean? Nano for science and technology people, what does it mean? Nano means actually prefix. Nano is nothing but prefix. Millimeters. Micro is nothing else. And nano associated with, what is the number that nano is associated with? 10 power? Means nano means are we talking about nanometer or are we talking about nanogram when we are talking about nanoscience and technology? Which one of them? Anni kuda na? So when I am talking about science, nanomaterial, what I am talking about? I am talking about a phenomenon. This is a meter. To connect the nanosecond conditions have to be fulfilled. Let's connect to the previous slide. So let's talk about nanosecond. Something has to be small. Is nanosecond small? Right? But in science, it is not relative, it is not qualitative, it has to be quantitative. Is something smaller than possible in time scale? Yes or no? Okay? Somebody is nodding head and she is saying no, it's not. You are saying no, right? Okay. But the answer is yes. If I want to give an example, when I am talking to you, when you are seeing me, some 10 power 8 seconds per meter meters per second kind of a speed, and you are responding, able to see me, right? This time scale, this entire thing happens at a second. What is 10 power minus 15 is there on the 10 minus 15, and in fact in 2000 Physics Nobel Prize was given for 10 power minus another second, right? So smaller. So nanosecond in time scale fortunately is not small. It's big. Okay? So not the second thing that we are talking about. Now my favorite question is that, you know, can somebody immediately tell me if I have 9 liters of water, quick. ఎందుకు 18 అన్నాను? Ten power 23. Density is so 10 power minus 9. 10 power 23 multiplied by 10 power minus 9. These are the standard questions that are being asked in India. You are not applying your mind. Okay. 10 power minus how much? 10 power 23 multiplied by 10 power minus 9. 10 power 14. Add it, 23 minus 9. 14 అంటే తర్వాత no way that number is small. Weight scale or volume of water, if you make a droplet of water, there is no superiority. There is no special. There is no speciality. Water will be. Again, some of you, when you write say that unique properties different from it is not different. In fact, if you want to make a special droplet of water, what do we say? Bulk water, which has some very water number of molecules. 18 grams now, right? 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 200 grams of water. Now less than 1000 molecules of water. You know how much volume 1000 will have? It will be a Zepto liter. So again, what is Zepto? Zepto is a company, right? Zepto is 10 power minus 21. Right? So Zepto is minus 21, which means that another 12 orders of magnitude smaller than nano. Right? Suddenly you are seeing scales in completely different way. Right? That's why actually they made the company Zepto, which is so become 10 power minus 21 seconds. Right? That's what they wanted to name the company. So again, time scale, and weight scale. Unfortunately, nano, sir, address on that. Sir. Okay. Both in weight scale and time scale. This is important. This slide is very important. A lot of time on this slide because it's associated with properties, right? So now when it comes to length, comes, and that's why. So what is nanometer? What is the action? This in length scale minus 9 nanometer. So 1 order of magnitude smaller, 10 power minus 10 meters, 10 power minus. If I you know this is the issue, right? You tell how you right or minus or 10 power or minus 10 meter. Anything that you take, periodic table is in the angstrom scale. Right? You associate 10 angstrom is 0.1 nanometer. 10, put them in line. What will be the time? 1 nanometer. Suddenly what happens in the length scale is that you are really going to the limit of what we can achieve. That's why fundamental is extremely important. Nanometer is fundamentally important, right? Not because of the properties and other things come later, right? I always tell every property is important and unique and useful. Property, whether it is insulating property, whether it is a conducting property, everything is useful. The only useless material in the world is an idle brain, not working. It's called idlebrain.com. Okay, it tells about movies, etc. You want to see it, you can see it. I am from right. Okay, I'm a big movie buff, by the way. Okay, so please remember that. We have completed all this slide. By the way, these are the 3 people who have the Nobel 23 second light pulse. In 2023. So we'll move back and then nano is a scale, right? Please do that. ఫినిష్ చేసుకుని మాకు అడ్డం రాకుండా ఉంటే చాలా సంతోషంగా ఉంటుంది. Okay, right? Okay, let us move ahead. Okay, so there are different things. Like so, nano sizing causes changes depending on the composition, depending on the material, depending on the size, depending on the shape. What's called morphology. Things do change. We'll go to nano size. Okay, let us move ahead. For example, some of the interesting properties that are displayed by nanomaterials are up. Right? What you are seeing on the slide, because many of you are probably not able to read the slide, what you are seeing there is nanoparticles of noble metals like silver and gold. Right? We never associate the colors of silver and gold. Right? These are not the colors of silver and gold, isn't it? Right? But for example, actually this is silver nanoparticle. There is gold nanoparticles which show pink color. Right? So optical properties of materials change. This is the first time people realize that properties of by changing their size, properties will change. This is a great realization. Right? Properties of materials change by changing size. We always thought that a property is associated, a color is associated with one particular metal. Silver is white. That's it. Right? We were told that. Gold is yellow. Copper is brown in the bulk state. Copper is not brown in the bulk state. It is completely different. Right? This is what makes them extremely. So, and as I said just now, right? That thing is in the size. Certainly that realization is extremely important. That's why nanoscience and technology is considered what is called a platform technology. It can be used in many applications because properties are tunable. You want a conducting material, I will make a nanomaterial which is conducting. You want a semiconducting material, I will make a nanomaterial which is semiconducting. In fact, sometimes the same material conducting in one size will become semiconducting in another size. This is unheard of, right? This is what is making nanoscience and technology extremely interesting and then useful, right? And today, I don't know why not take care of two of these applications, energy and medicine. So, okay, let us move. So, sir, so I know how to make these nanoparticles. Can I start using them for any application? Right? I know how to make nanoparticles. I make a nanoparticle and start using for, right? Is it possible? I make a nanoparticle, want to use it for energy. I want to make a nanoparticle, want to use it for medicine and drugs. Unfortunately, the answer is actually, do you know what are they looking for, and do you know what is the application that you are looking for, and is there a match? And how do you make this matching, right, between the type of nanomaterial that you make and the type of application that you need, right? It's almost asking what kind of a dress I am wearing, right? ఇవాళ నేను ఇక్కడికి వచ్చాను ఇలాగా, రైట్? ఈ డ్రెస్లో పెద్ద కోట్ వేసుకుని, రైట్? రాత్రిలో పడుకోనుగా. Do I sleep like this? Or if I sleep like this, I will consider silly or stupid. Right? ఈ విజయవాడలో ఈ డ్రెస్ వేసుకుని వస్తే నా మటాష పోతా లోపల. Right? So you need to understand what is the and then make your nanoparticle. That's why I actually Tyler, right? So the other title, but whether it is styling, whether it is problem into different levels, right? And I want to convince you now that Manish Malhotra తెలుసమ్మా? The name right? I am from Vijayawada. అసలు ఈ నాలెడ్జ్ విపరీతం మనకు బాబా విపరీతం. ఓకే, ఫస్ట్ వాల్యూ 0.5 2.7. Okay, this is what we are good at. Let us move and then talking about science. So how do we connect these two professions, scientist and a designer? person is going through, take a measurement. Right? Right? So you need to making whatever it is. You need నేను అంత కొట్టించుకుని వాడికి డబ్బులు ఇవ్వాలిగా అంటాడు. రైట్? సో దిస్ ఇస్ ఆల్ ఇంపార్టెంట్. లైక్ వైజ్ మనకి బట్టలు పెట్టేటప్పుడు కదా ఫస్ట్ ఆ పర్టికులర్ డ్రెస్ కి సరిపోతుందా లేదా, సార్ ఇది 1.1 మీటర్ ఉంది సార్, మీకు సరిపోదు, ప్యాంట్ రాదు, లాగు వస్తుంది అంటాడు. రైట్? సో యూ నీడ్ టు థింక్ అబౌట్ నౌ వెన్ యూ material for an application, you need to think about what is called sustainability, whether this material is sufficient enough there for sustaining for long time. Right? Sustainability is important. What is the application? What is the design? What is the affordability? Now this is the connection between a tailor and a cyclist. The thought process has to be the same. You need to start with that thought process, right? So please remember that. Okay, so again, what is the importance of trust? This is where I said that I will use a lot of analogies, right? What is the importance of trust in our lifetime? I hope none in the audience, including me and probably even the other chief guest, Dr. Ishwar Prasad, were born with a dress, right? Are we born with a dress, right? All of us were born like this, right? Even this is not there, right? When we were in the mother's womb, nothing was there. We were all like this, right? Agreed? Any difference of opinion, sir? No, wonderful. Yeah. I'll buy this. ఇక్కడ కొత్తగా పుడుతున్నారేమో కొత్త జనరేషన్ పీపుల్. ఓకే, దే ఆర్ స్టిల్ born same, right? Okay, so we are all born. Suddenly, within no time, we change to this. Immediately after, right? Immediately after, and these days, వీటితో కూడా ఫోటో వచ్చి she knows all, everything she knows. Okay, don't take it to her, right? Just to deliver my talk using the analogies, right? So ఇక్కడ ఆగిపోయామా, ఇవన్నీ టవల్ కట్టుకుని రాలేదుగా, right? So then we start using this, and then we start using this, and then we start using this. అసలుకైతే నాకు పేరు పటాహువాజీ పేరు చెప్పారు. ఓకే, ఎక్కడెక్కడ చెందుతాయో తెలియదు భయం. వేరే డ్రెస్ ఉంటాయి, క్యాప్రీ, అనార్కలి, ఏంటమ్మా. I have 2 daughters. Be silent. What I am trying to convince you is that we are not satisfied with one design. We want to have different things. This is basically to make a fashion problem. It dress better, right? You can't wear this dress, right? Or you can't wear this dress, especially Vijayawada, right? So you have to wear season also, right? And you also have to wear the dress. Otherwise, if you don't wear the dress according to the season, you might be, I don't know what is doing, right? Right? Or like you coat, jacket, tie, but like forgot the umbrella, right? Right? Very soon, right? Please understand, this is what it is. You need to prepare yourself for a particular occasion, season, environment, whatever. This is mostly to this. Okay, so you need to match these 3 things. So this is, who is this guy? This again, we know all of them. Okay, all of them. So this is Virat Kohli, this is Virat Kohli, this is also Virat Kohli. Of course, this is called Virushka, I think. Right? You cannot call them Virat Kohli anymore. These are all very offended. You have to call them Virushka. What are they doing? What is Virat Kohli doing here, sir? Fielding. Very good. Understand? You are right? The dress he is wearing or the attires he is having, gadgets that, see, you understand things, right? It is the thought that is happening. It's automatically happening because we have some prior knowledge, right? So I'll come back to that. So this is the correct answer. Again, who will answer like this side, right? So again you have to match. మిమ్మల్ని మీరు వెతుక్కున్నారు కానీ వెయిట్ చేయండి, రైట్? బ్రైడ్ గ్రూమ్, this is the right dress. పెళ్ళైన తర్వాత అంతా అదే. Right? Tell you is who told you has to be this? Nobody told. We got imbibed. మన మెదడులో వైర్లు వచ్చేసినాయి, అలా కనెక్ట్ అయిపోయింది. దిస్ హ్యాస్ టు బి బ్రైడ్ గ్రూమ్, దిస్ హ్యాస్ టు బి వార్ హీరో, దిస్ హ్యాస్ టు బి మౌంటైన్. అట్లీస్ట్ దీస్ టూ పీపుల్ హ్యావ్ టు డూ బికాస్ దే ఆర్ డూయింగ్ ఎ వార్, బికాస్ దే ఆర్ హీ ఈస్ క్లైంబింగ్. ఆ గుర్రం ఎందుకో తెలియదు, పాప ఎన్ని కష్టాలు తర్వాత. ఓకే, ఎనీవే, సో నౌ లెట్ us right. And here I will use the function. Right? There being used for, right? So let us do that. Integrated chips, ICs, etc. Like whatever the things that we have using light and the lithography, writing, right? Whereas the new technology will be by screen printing, right? Which is what we call a roll-to-roll technology. Usually, which if you have ink. So what we are in the labs is that make nanomaterial based inks, and once you make nanomaterial based inks, ICs, etc. Right? So don't check anything out. I think we have missing the time, right? And let us go ahead with that. Okay. So please remember that. So the future electronics industry will be dependent on nano based inks. Which should be, there is one thing that you should remember. The second one is okay, so don't think that I am a Savlon sales agent. Okay, this particular video at the end will show, if I go, it will show this Savlon hand wash, which is hardly 20 rupees. These are silver nanoparticles. The screen printing applications, which are high-end applications, also using nanoparticles. And there is another video, again, unfortunately it will not only play, it will not play, right? So this one is using nanoparticles for drug delivery applications, especially for targeted drug delivery, where you only deliver the drug to the location that you want, especially these two cells, one is the cancerous cell, one is the normal cell. You want to deliver the drug only to the cancerous cell. This has extremely important ramifications, because right now anybody who treats cancer is suffering a lot. Right? They use a lot of hepatitis and other things, because the cancer drug is highly toxic. Highly toxic. It works every cell. That's every cell. Now you cancer cell and not to so three important different applications I have shown you. One is in screen printing application, the other one is hand wash, the third drug delivery application. Can you use that same nanomaterial for all these three applications or for all these three functions? Again, the answer is no, right? Let us now understand what are the requirements. Now I come again like a tailor, right? What are the requirements of nanoparticles for being used to particular application, right? So applications, the nanoparticles should be dispersed. Okay, always remember, this is a solid particle dispersed in a solvent. Therefore, you use the word, you cannot use the word solution, right? Don't use the word solution. Whenever you or any other solvent, dispersion, right? So, nanoparticles should be dispersed in a solvent. Right? If they have there are other conditions, but they also should not undergo what is called aggregation. They should be stable, right? So you have to have stability as a dispersion. For stable as a dispersion, but water, not in a non-polar organic solvent. That's my attendance, చుక్కలు దాటుకోవట్లేదు ఓకే మా మధ్యలో నేను చుక్కలు ఆడుకునేవాడు నా పేరేసి నీ పేరేసి అయ్యో రోజు ఆడతారా ఓకే ఎనీవే సో బయోరిలేటెడ్ అప్లికేషన్స్ nanoparticles should be in polar solvents or water like solvents, and they should not prevent aggregation. They should not have any aggregation. Of course, one condition should not have any toxicity. Toxic, the drug is very toxic. You cannot have toxicity. Now, particles, what is called a top-down approach, the other one is a bottom-up approach. The top-down approach, you take it and make it small. This is top-down. Big to small is top-down, right? What is bottom-up? Small to slightly bigger. What is small? I told you. Is smaller than a nanoparticle, right? It is a 1 angstrom size. So I make an atom, assemble them, and then that becomes a nanoparticle. That is bottom approach. Right? How many of you seen old Amitabh Dharmendra Sholay movie? Not Ram. Unfortunately, you are all corrupt in that movie. Dharmendra will be a water tank, and then he will say that checky piecing, right? Like checky piecing is nothing but theoretically. Okay, so that is top-down approach. You take a bulk material, you take grain and make it powder. That is top-down approach, right? So make an atom. How do you make an atom in the lab? Can you make an atom in the lab? Or can you synthesize? Can you prepare an atom in the lab? Yes or no? Chemists, you all should be feeling proud of physicists, like, no, we can make, right? So, we basically have to take a smaller than a nanoparticle, or smaller than an atom, right? What are smaller than an atom? Ions are smaller than an atom, right? Sodium ion, or you take iron ion. What is the iron ion? Which plus? What is the stable oxidation state of iron? Or what are plus 2? Plus 3 is the better stability, right? are available. What is plus 3 mean? What does it mean? Oxidation state. What does it mean? Yes, there are three electrons less. It is supposed to have some number of electrons. It has less, 3 number of electrons less. If you supply those electrons, atom, right? It's called supplying of electrons, adding electrons to a particular. You know this perfectly, you are not connected. Exactly, we do it today also. System. The type of reducing agent take these activities, right? That may be slightly not known to you, right? So we see electrons, right? And
nitrate and sodium chloride, solution of silver nitrate, which is colorless, chloride, which is also colorless. So,
yeah. Unfortunately, so we said that I told you that gold displays beautiful optical properties. Gold, to make gold, what we do is we take gold precursor. Gold precursor also AuCl3. AuCl like FeCl3, AuCl3 gold precursor. 3 plus oxidation 3 electrons using sodium citrate, right? But converted it by sodium, right? Take and that's it. If you know what concentrations you have to do, what temperatures you have to treat, you will beautifully see the formation of gold nanoparticles. With your beautiful color that will form. Unfortunately, again, this video may not play, but right. So now this is a transmission electron microscopy image of a nanoparticle. What you see there as a disk is actually a spherical particle. Right? You actually shine an electron beam, and it's a two-dimensional image of a three-dimensional object. If you put a to them. When you start applying them for an application, they are undergo irreversible aggregation. These nanoparticles, as I said, are basically likened to a naked baby. What will happen if a newborn baby is born? Some person displays Bahubali, right? No, right? You immediately try to protect the baby. You make a nanoparticle, you also have to protect them, right? So this is where, again, what is the talking about? Protection of nanoparticles. This process of protection of nanoparticles, right? This is the original paper by Mongi Bawendi, Chris Murray, and Jen Norris in Journal of American in 2023. Right? By the way, you should read about Mongi Bawendi more, and then actually 3 of them given Nobel Prizes. This is Mongi Bawendi, this is Lu, and this is Alexander Ekimov. These 3 people were given the Nobel Prizes for how to make nanoparticles, right? I was lucky to have interactions with some of them, especially Louis Bruce. This is Louis Bruce, and then so this is what it is, right? So you need to know how to protect nanoparticles. Extremely important thing. It's a beautiful discovery, right? Okay, somewhere in 1994, 1993, it happened, right? So this is a naked nanoparticle. How do you protect the nanoparticle? By putting a layer on the surface, like a dress. Right? And what is this dress made up of? This molecules. This times amine, R primary amine, right? RSH is called thiol, right? RCOH is called carboxylic acid. Wonderful, like all the 3 are amine, thiol, carboxylic acid. These molecules will go behind nanoparticle surface. There is an organic, inorganic hybrid, and these 3 functions go and attach to the nanoparticle surface, right? So this is how they do, and then I think since the original discovery, like surface modification of nanoparticle research, and as I said, 2023, it was given the Nobel. These molecules bind to a nanoparticle surface, right? So have this molecules elaborated here. There is an X group here. What is this X group here? This is what it is basically an amine or a thiol or a carboxylic acid. This is what is called an anchoring group or a binding group, right? And this length alkyl chain, at least 6 carbon atoms or more, imparts the stability. It doesn't allow the nanoparticles to aggregate, right? So you two cannot aggregate because there is a barrier here, right? This organic molecule provides barrier from nanoparticles to aggregating, right? And this particular end group, this provides the functionality. I will elaborate on that a little while later. Another 10-15 minutes I will be done. Okay, be prepared. So please have patience up to that time, right? Methyl group, right? You make a nanoparticle, the end group is CH3 molecule. These nanoparticles can be an organic solvent. They can be dispersed in an organic solvent. They can be solvent. They can be redispersed. Right? I told you the toroidal dispersions are weak, right? Right now I am able to precipitate and precipitation and redisperse. Right? Now you have solved one problem. They are not aggregation. Right? You are making powder, and whenever you are powder, you say dispersion again. Right? So you have solved one problem, and therefore printed electronics. Wonderful. One problem solved. Now we have to solve nanoparticles can be used for related application. Unfortunately, no, because these nanoparticles can only be dispersed in non-polar solvents. They cannot be dispersed in water. Right? What is the problem? This particular fellow, this particular length, and then this particular fellow defines the surface of a nanoparticle. Right? What the environment sees, right? What? You are not able to see my body, right? X-rays. Huh? Me, right? Without the dress. Right? What is there inside you don't know. Isn't it? Right? Likewise, you cannot see the nanoparticles. Once you cover these nanoparticles with all these ligands, you'll only see the ligand. And how the ligand behaves, the nanoparticle behaves. Right? So right now this ligand is hydrophobic. This ligand is hydrophobic. It means it doesn't like water. Now if I make this love water, if I can do that, then if the exposed functional group is hydrophilic, then those nanoparticles can be dispersed in water. And not only they can be dispersed in water, they can be precipitated and redispersed also. Right? But you should, right? Okay. Sweet loving people. We are sweet people. I am a sweet person, right? So let us use sugars. Start making a molecule which has a long chain and a functional group, carbohydrate and a sugar moiety. Right? If I attach this particular molecule to a nanoparticle surface, these nanoparticles will make some silver nanoparticles. Here, using this molecule this is called a sulforolipid. This molecule is called a sulforolipid. Why is it called sulforolipid? Because a sulforose is a dimeric glucose, right? A dimeric glucose. Sugars are called, what are the names of sugars? Glucose, fructose, maltose, galactose, right? All O's, right? So this is a sulforose, right? So not a rose, but a sulforose. Roses will come. February 14th, some rose will come, right? Okay. So be ready, right? So this is sulforose, luckily, right? This is sulforose. The sulforose is attached to a lipid, so this is called a sulforolipid, right? So this sulforolipid, if it is attached to a nanoparticle surface, these nanoparticles can now be precipitated and redispersed in water. That is a beautiful discovery, right? At least we are proud of that particular discovery. We are really proud. Now, right, let us move. I mean, I think we are getting bored, right? I need to know these analogies, okay, always. So, these nanoparticles are not dispersible in water, but they are not yet functional, right? They are not yet functional. I only solved one problem, that they can be dispersed in water. How do I make them functional, right? To add the functional, you can do a 20-minute discussion. Because right? Ask me, right? Okay. So what is happening is these two people marry, right? Okay. And they want to get married diving, not diving. Diving is afterwards, right? So this is right? So okay, వాళ్ళిద్దరూ diving చేద్దాం అనుకున్నారు, okay. Poor fellow, he is old, he will dive చేయాలి, okay? Father, ఆయన ఇదిగొట్టున్నాడు. Leaders వస్తున్నారు, okay. ఆయన ఎందుకు అవడం? Anyway, that's a different matter. But the interesting thing is, I want you to not worry about marriage, wedding, all those things come later. Worry about these things, right? They are also wearing a parachute, right? So that is the functionality that is attached. Another functionality that is attached, right? So how do we attach functionality to our nanoparticle surfaces? Right now we made nanoparticles dispersible in water. How do we add functionality, right? So we did one work where we took some naturally occurring sugar. This is called K.B.N gum. This is a food additive agent. I remember again, water dispersion, and it should not be toxic, right? Whatever I add to a nanoparticle should not be a toxic, right? So this is a molecule that is used as a fruit preservative as well as thickening agent. Gels antar kada. You make gels, right? You are adapted that. You make good gels, right? So you add these K.B.N gum and it becomes a gel, nice gel, right? So this is edible. You can eat that, right? So it's a fruit, from fruit it is extracted. So we made nanoparticles using K.B.N gum, and on top of that we decorated that with a drug molecule, right? And this K.B.N gum is nothing but a sugar, right? It's a sweetening. Sugar, what happens is, when especially people have what is called brain cancer, right, brain tumors, so drugs cannot be delivered to the brain because there is a particular barrier called barrier, right? It doesn't allow blood to go into brain, or like, it doesn't allow many molecules to go into brain, except some sugar molecules, right? So therefore, we got like these sugar molecules coated nanoparticles, because I told you, the environment only sees the cover. It will not see my body, right? It is only seeing my surface, right? Because the surface is covered with sugar, we thought it can be basically crossing the blood-brain barrier. And indeed, we were lucky to show that these drug molecules were delivered into the brain, and then brain tumor cells got killed, etc., etc., right? So again, it's a beautiful video. I hope at least listen to the beautiful song. Okay? Who is this guy? Experiment by Sonu Nigam. Of course, in the let us stop. Okay. He was performing on Bombay, sitting on a pavement, in a corner of a pavement, right? With this disguise. Right? He is not like Sonu Nigam. If he was Sonu Nigam, he was right? But he was in a disguise, right? Nobody cared. Begging, he was begging on the, you can go at Google and then see, it's a real. The New York experiment was done by another violinist who did that in the New York metro station. Right? This was a repeat experiment in Bombay. Nobody cared. Nobody even gave 1 rupee to him. Right? The same evening, Sonu Nigam was performing in a stadium saying that Sonu Nigam performs for you. Ticket was 5,000 rupees. And tickets were not available. Right? See the difference? Are we paying to listen to the song, or are we paying to see Sonu Nigam? Right? Okay, so this is what, now what is the message for us? Right? I am not doing good, this is not bad. What I am trying to preach you is, you can make something, some systems fool, or you can fool some systems, right? How do we fool the system? So the way we quoted some are same, albumin is more commercially available. We coated that molecule with this protein, with the protein, and this now being taken up by the very fast. But unconscious, they grow. So isn't it? So provide the food to the nanoparticle, the cell. So cancer cells will take more to normal cells. Not only that, it is food, took it inside, but the drug got to kind of solve the problem of cancer and all those things will be detailed. So here you can see these are brain tumor cell lines again, LN229, the normal fibroblast. The drug is not delivered here, but I hope you are able to see these red dots here, right? These are nanoparticles loaded with dye molecule. To see them, we have loaded them with the dye and drug. So this is the dye, right? Dye called hexastrand. Okay. So the
journey, AI, ML will just replace all those jobs, right? Your jobs are not going to be replaced in any time soon, right? Your skill set is unique. Please be proud of it. Please engage yourself. Like, so, మనం ఇంట్రెస్ట్ గా చదివితే ఏదైనా వచ్చేస్తుంది, right? So please engage yourself. ఎంత ఇంట్రెస్ట్ గా మనం తగ్గేదే చూస్తామో అంత ఇంట్రెస్ట్ గా ల్యాబ్ తగ్గేదే సరేనా? Then you will be out. Thank you, sir, for prompting that question.
Sir, one more question. Sir, is there any lab establishment schemes for nanosciences and in academic institutions, funding agencies?
So that I have no idea. Frankly, I don't think so. But there is a similar program existing for teachers. This is called TARE, Teacher Assistance for Research Establishment, right? So a teacher can write a program jointly with the lab, right? And the teacher is given funding to carry out the research work in their own lab, in their own organization.
Okay, sir.
And also invited to spend at least 3 months a year in the lab where that lab is being hosted, right?
Associate.
So yeah, so that is another program for only for teachers, right? This is called TARE, some people call it TARE, whatever it is. Okay? So this is a beautiful program.
I think this comes under DST service.
It's a DST service. Yes.
Thank you, sir.
Right
Thank
now
you.
it's A now.
Thank you, sir. Thank you, sir. Thank you for you have given a wonderful lecture. What to do with our research work that we could not take it further as originally thought. So in this talk, sir has enlightened our students. So what is nano, the nano and auto, and you have explained about how nanoscience is around us, the senses of the nanoparticle, the top down, top up, and what is an atom to nano and a molecule. You have also enlightened about how to make a nanoparticles and knowledge about the applications of nanoparticles, especially in drug delivery and mainly in the cancer therapy, and how use the nanoparticles cancer cells. And also discussed about the many various aspects and research gaps in the synthesizing the nano, that is the milligram level to the kilogram levels today, sir. And thank you, sir. Thank you for giving this wonderful lecture, and I hope all our students has enlightened. Thank you very much. The next session is a lecture given by the Professor Dr. K.B.N. Prasad, sir. So here, sir has many 20 pages of his biodata, but I am very concisely reading only a half page. That is, Dr. K.B.N. Prasad, sir, is a BTech.
Cells are more and more nanoparticles, not normal cells, right? So this is how we could show all these things. Okay, I think more or less 2 more or 3 more slides. I will close. Remember my title of the topic: what do I do with the research where I could not do what I wanted to do? So we wanted to do all this.
1985 in 1993 from prestigious IIT PHU Metallurgical Engineering Department and has superannuated from the Ministry of Defense as an outstanding scientist of DRDO and Director DMS RDE Apple. He is presently with the MTIT of CBES Hyderabad, a mountain institute of R&D activities that are relevant for academies. Dr. Prasad, an innovative and a creative and technologist. His major contributions to material engineering and defense system evolution include science and technology, design, development, airworthiness, certified production of many advanced aerospace and special functional materials like aluminum and aluminum lithium alloys and many and areas steel for Indian missile programs, high strength and high temperature tin alloys, many advanced ultra temperature materials and many other one page are there. And Dr. Ishwar Prasad is recipient of more than 80 national and international awards. I'll read at least one or two. First, Young Scientist Award in the Material Stream, Indian Science Congress 19. Young Metallurgist Award of Indian Institute of Metals from Ministry of Steel 1994. Binani Gold Medal IIM 2006. National Metallurgist of the Year from Ministry of Steel and Mines 2010. Totally 80 hours are there. And finally, SAR is a visiting scientist of Max Institute of Metallo for Shedding and Stuttgart Alexander von Humboldt Research Fellow from Germany 1998. SAR awarded 6 students PhDs and one of the students pursuing PhD. SAR more than 800 publications in a peer-reviewed national, international journal. SAR has more than 500 citations with 31 H-index and I-10 index is about 115. With this very less or brief introduction, now I will like Sir Ishwar Prasad Sir deliver a lecture to students.
Members of all these publications and all there, Prasad will have plenty of them, much more H index and I index. These are not the index, the contribution of a scientist or an engineer, you people destined to go to lengths by pursuing your science. Science is something that you understand fundamentally, okay? Whereas engineering, you take that fundamental knowledge into a phenomenon, when a fundamental knowledge or a fundamental phenomenon is engineered, is made into work as solution is called engineering. We do engineering, we are all by profession engineers. Whereas you people are supposed to do newer discoveries. Science is nothing but study of nature. When you study anything in your own words and able to explain to somebody by orally or write a research paper, and communicate to somebody, and later if you pursue that science for 20-30 years, you will get a name for your contribution. That is scientist. Whereas engineer, when the solution goes to a product or a system by technology, he is known as a societal value. We'll see that in my slides. When they'd asked me to talk about functional and engineering materials, I thought this is a good topic to talk about, because recently we published a Springer book volume, 2 volumes books, okay, on functional and engineering materials. In fact, the conference title is the functional engineering materials, smart materials, functional smart material, entirely functional materials. I also included engineering materials because many engineering materials today without functionality are not useful, okay. So that is the topic. I devised my talk in such a way that you will see the applications in many other products where both are covered. I also devised the schema presentation. If you see, I am talking about the materials and classification. Prasad talked about, why this fellow is a groom, why this fellow is a soldier. It's all nomenclature, okay? A soldier is always a groom, You would have married some girl, So it's not it's a nomenclature. In engineering and technology and systems, we develop a nomenclature so that we can classify several sets of applications or materials, okay? Around 10 lakh materials are there in the engineered materials. I'm not talking about naturally occurring materials. A biosystem itself has got millions and millions of materials, right? So the species are not I'm talking about an individual material, that 10 lakh of them. 1 lakh of them are engineering materials. That means you use day to day 1 lakh materials, 10,000 alloys. And Prasad is working on high-end alloys. I will not talk about all of them. There itself you have around 2,000 to 3,000 alloys which are, synthesized and evaluated in the last 5 to 10 years. So the materials is a constant evolving field. But the underlying chemistry or physics principles are fundamental. They don't change much. But how you use them is a very important knowledge. So I devised my scheme of presentation as materials and classification, talk about fundamentals, and many physics phenomenon will be involved in that. Then I talk about nanomaterials, and more importantly, what all the Indian programs for the nanomaterials. Prasad talked about only the student one. I'll talk about many more. There are many national programs that are available for each student to go and take a good exposure at a national level. I'll talk about them. Then I will cover the flexi electronics. India is not able to do the electronics very high level because our import costs are much lower than the Indianized production. Indian production costs are much less compared to imported costs. So the government always looks at how much money a common man has to spend. If Ishwar Prasad says, no sir, we'll take my nano electronic or my flexi, government will not allow. And if I set up my own company, if I am not able to sell at a price which is, much higher than imported price, I will go bankrupt. Simple. Economics only determines the markets. Whereas the product quality determines the value of the product you take. But ultimately we are all looking at a effective money. Suppose you are using 1 lakh rupees on your mobile, you would replace it or take another one which is coming for 90,000 if it is much better. Okay? Brand value and all, you leave that to the marketing. Okay? So the flexi electronics is something that Government of India had identified to look at as an import substitution. I'll talk about that briefly in the end. Can we go to the next slide? Page down. So the first is, I told you, there are 10 lakh materials. How do we classify them? Go to the next slide. Very uniquely, the matter, if you take the physics, we say that solid, liquid, gases are gases, liquid, solids. Solid, liquid, gases are the temperature increases or the temperature decreases, the reverse. Right? That is a fundamental way of matter classification. Then we talk about, very important for all chemistry people, the second talk will cover that, metals, non-metals, noble elements, lanthanides, actinides, all these things are covered based on the electronic structure. Okay? Then the third is most important for us, the engineers. We look at the functionalities and properties. We talk about the functional properties like conductivity, magnetism. Physical properties are also extremely important for aerospace applications. If you want to send a heavy metal based system into air, you will have to spend a lot of fuel. It's not done. So the aerospace is a very fundamentally low density materials. Similarly, if you take the structural materials, very important is many of them have to last 20 years or 30 years of service. Okay? Many people do not know the aircraft that you fly is 20-30 years old. Many of the Air India flights are 20-30 years old and they are flying every day 5-6 hopping flights. Okay? Calculate, and somebody calculate 3 or 4 flights a day and then 365 days in a year, multiply 20 years. Those many number of times the aircraft goes into the air and lands, and each time it goes to the criticality. So that is the level of structural efficiency it is required to take back the money. Each aircraft is 200 to 250 crores. So what all the money you pay in terms of the transportation or the ticket charges, they are the only driving force. Okay? So that much is required, and this is a classical slide where I teach, I can teach this slide for one complete course. But here you should know, in the solids, there are crystalline, very important, most metals are crystalline. That means there is a long range order. If you put all these chairs in one line, you can find out whenever there is one chair is missing. That is called interstitial, which is missing, like that. So you can find all these crystalline defects, things like that, and that's where most fundamental functional properties will come in the second, what you call row, where atoms, ions, molecules go to the quasi-crystalline and amorphous, that the functionality get generated there. Whereas the structural properties come in the all other places. Okay? That's all you need to know in this slide. I can explain for length, Next one. These are the basic slides. As I said, for engineering, you have to move from the science to a property-based classification. For example, biological. Somebody talked about drug delivery. You have a human cells, so it's nothing but 4 fundamental genomes are the basic molecules in a body are only 4. Metals are many, alloys are many, but the chromosomes are made from only 4 molecules. But their defects are innumerable because you have a length of them and where they come, how some of them will become cancerous, all those things are the defects in the human genome. Okay? So that's all the biological, electrical, electronics, dielectrical, all those things. Optical is how the material responds to light. These are all the important properties we'll study in the course of, say, from 8th standard to MSc, we'll study all of them at different details. Next one. So in the engineering materials itself, you can again classify them into various applications. Okay? And each of them, some countries are extremely good in making these materials into their national value. For example, India has been blessed with fantastic refractories. If you go to the Ganges side, the foundries, where you get all casting, metal castings, come because the Ganges mud has got a lot of clay. So the casting of those metal parts are very intricate and you can get a lot of money. So like that, we have to exploit our nature so that we'll get money without disturbing it too much. Then these are the materials which also gives wealth in a long term. For example, if you are able to construct a good house, it will come for 40-50 years. But imagine if you, nowadays, they want modular houses. After 5 years, they want to change the bedroom size. How do you do that? You can put up moving pillars in an iron structure. And then you have a decorative one, even insulation into that is the wood structures. These are all the ones which the world is moving into. Okay? So these are all possible to do when you engineer the engineering materials. Next one. These are important. All this PDF will be available to all of you. Don't worry to take down the notes. But every speaker wants some questions to come. That shows how much I have spoken, how much people have understood. Only for that reason. These are all the various new technologies or products or materials that we require for India. Our nation requires all of them. Each one of them is taking away all our money. So make sure that you study these and look at, you can go to internet, ChatGPT, etc., etc. They all come for a transient time. We have seen many fields coming for 5, 10, 15, 20 years. They make a dent little, but they move away. Okay? They serve for limited time purpose. Later, what remains is the fundamental knowledge and fundamental applications. Okay? So these are all the ones as of now required. So please make a note of them. I had included this slide only for your information's sake. This will not be available in any textbooks. Okay? Next one. These are all the smart materials. What we call a smart material are these new materials. In fact, I should have put new material technologies. But I was talking about technologies in that slide, so I did not make, the top materials itself shows the category of technologies that we require for these materials. When you know these materials are required, they have several applications. I had put it here. And of course, since I come from defense, I always make defense application topmost. Second reason why defense applications are taken is we test the materials in defense at the highest level because we have to win over the enemy. Okay? The person who is trying to shoot me, I should have better protection, shoot him back. So That is what is defense. We have to get the world best. There is no question that we give any second rate or second solution to our soldier. The soldier will not exist otherwise. So we have to give the best materials and best technologies to the soldier. So when we do that, all other levels of products, the cost of the kind of a world-beating material and the system is very costly. For example, Rafale, fighter aircraft costs more than the transport aircraft, which is 10 times bigger in size. Why? Because it can bring down the enemy's plane very easily. Whereas a normal transport aircraft, whatever you and me use every day, they cannot have any protection. Okay? So that is the reason value generates in the defense systems. And defense is the one that, we can translate to different levels. It is at this level at a cost basis or functionality basis. But as society, in the commercial one, we require only half of its capability. But maybe it requires better life. Then we'll have to see that. Next one. These are some of the things which you people will teach me more than what I know. The magnostriction is nothing but a phenomenon. When you apply a magnetic field, the physical dimension changes. Okay? So when you do that, that acts as in fact it's a video. I'm not playing the video for the paucity of time. Okay? And it's a PDF, so video will not be played. Okay? So this, you see, so many applications have come for this magnetic phenomenon. Okay? And every missile requires this. You give an electric pulse from your motherboard in the missile, that has to move in a particular way, and that only gives you a movement of missile going here and there. Because it has to go and hit the other missile or any other object. So this is a very important technology. And the effect is, many phenomena are derived. The effect of just giving one electrical pulse to a magnetic material, how the physical shape of the material changes is a fundamental phenomenon. Joule effect is the one which is famous on that. So you people will have to read various effects of this particular magnetic field or magnetic phenomenon. Once you know that, you can create n number of applications depending upon what is required. For example, an automobile, simple automobile, requires around 10,000 permanent magnetic materials in different shapes to use it in the car. Your car might be only 3 or 4 lakhs even, but it requires 10,000 magnets, permanent magnets. India doesn't have permanent magnets. Okay? We are all importing all those magnetic materials from China. So how do you rid of Chinese economy? We cannot. So it's interdependent, but it's an international level. The trade is an international one. We don't have to bother. What we have to bother, whether we can own up some mines in China and make a good, other than Chinese territory, get good mines and get our material, make it economical compared to Chinese supply, which is very, very important to do. So this is one area India is lacking behind, and then we'll need to do our own technologies to do that. Next one. The ferromagnetic, somebody asked, no, why Fe+3, Fe+2? Fe+2 is less electropositive compared to Fe+3. It can take per atom, per ion, more electrons. Okay? That's all it requires. But look at the properties. Again, these are the same. I put intentionally for same application different solutions. Here, instead of electrical pulse and looking at the dimensional change, I give a magnetic pulse. And then you look at the temperatures of application. Tc is the critical temperature at which these materials can be used. These will be much higher compared to the first set of materials. Okay? So if a temperature of the material is required to be used at higher temperatures, we have different solutions of materials. Understood? So the material what I talked about, 100 different materials come from the first set, will not be applicable for this. So the room temperature applications are different, the little high temperature applications are different. Okay? Next one. This is a magnetocaloric effect. Go to the other side. Instead of giving a heat or energy, we take out the heat, refrigeration. Magnetic also gives the reverse phenomenon. That also consumes energy. It is not that refrigeration doesn't consume energy. the net heat coming out is going to be more than what heat you are given by electricity by this mechanism. That's how the refrigeration goes, cooling. Okay, temperature of the chamber goes down. Doesn't mean that, we are able to extract heat from the refrigeration. We have to give heat or energy to the refrigeration, but the output, the entropy generated is much higher than what heat would have given it to an ideal system. This is what is the refrigeration. Again, look at the materials. Different, same effect. But here, we extract we have the entropy much higher than the refrigeration. Again, look at the materials. They're different. Again, using the same effect. But what we have is a totally different temperature regimes. The temperature that we cycles will be T0 and T0. These are all going to be totally different. These are the engineering. Different temperatures, supply energy, put a refrigerating agent, then look at the entire effect. That explains this entropy and temperature curve. Okay? If anybody is interested, he can do this one in the chapter that I am going to tell in the end. Next. So on to the part B. So far I talked about only magnetic material properties as a fundamental property of physics. And I explained what different materials get generated and then showed you what is positive effect. That means you do a temperature increase or decrease to do different applications. Now let us go to nanomaterials. Nanomaterials have come into a big way in 1980s. Okay? 1980s when we were studying, nanomaterial just made a way. Then somebody said, why our precipitates in metals is also nanomaterial? The precipitates in, say, aluminum alloy. If you take a pure aluminum, add copper to that, do a heat treatment, you get what is called Al2Cu, theta prime. And that gives a strength to the aluminum. Okay? Simple aluminum copper gives you a strength that is almost specifically equal to steel. How does it come? It is come by this precipitate. What is the size of this precipitate? 15 to 20 nanometers. Same as nanomaterials. But that is not the definition of nanomaterial. Nanomaterial should exist in one of the dimensions at nano level. Okay? That means if you are making a sheet, the thickness of the sheet should be in nanomaterials. Okay? That's where the multi-layered graphene is also a nanomaterial. Or a nanoparticle, or a nano sheet, or a nano, even agglomerate. You can have a nano structure, but in which all three dimensions need not be 100 nanometers. Only one dimension need to be in nanometer, 100 nanometers maximum. That's where the definition of nanomaterial. Then let us see the nanomaterial programs. I myself, without being a nano expert, I had devised many programs. Next one. So look at the international level. You have a roadmap created in 1990 by US Air Force. Okay? Still some of them are not achieved today after 40 years, 35 years. Okay? So why? That is because every time the benchmark is lifted, okay, US defense itself is asking more and more from their scientists and manufacturers so that they take services or take products only from the top people in the world. They have to filter away. So that's how they do. Every time they increase the specification so that only one or two companies in the world will be able to bag US or advanced countries' orders. Okay? That's where all this, the materials, the electronic data processing capabilities, sensors and components. In fact, this slide I've been showing for 10 years. There's no much difference. The competitors are the same. Everybody raises their benchmark. So the challenge is the same. Next one. Look at the DRDO program. I was myself the convener when I was in the scientific advisor's office in 2006. We identified these, and still they are not achieved. For example, the batteries, fuel cells, membranes, still India is working on them. So materials and material solutions, you will have a short-term supply, but a long-term supply comes from continuous effort. You have to put an effort, generate the manufacturing units or industries that generate these materials and take it up to the applications and commercially give it to the society is a 20-year process or 30-year process. If some are good, that products will last for even 50, 60 years. So all this these materials, Prasad has talked about conducting inks, which are used now in a big way. But this research in conducting inks, the top one is the conducting ink. That's been identified 25 years back. Okay? But how to do it in a tonnage level is a technology now. Okay? That's the manufacturing technology. Next one. These are some of the things a single laboratory in India has done. Many of them have gone to commercial applications. Doesn't mean that you will get it in your pocket. Still higher level of production is required if a common man has to get it in a shop or in a store. Okay? That's where all these one are there. And then look at the bottom two, where the nano is exploited for torpedoes. Torpedoes is like missiles under the water. Okay? When you do that, the propulsion required for that, if you use nanomaterials, it becomes very, very efficient. Because per gram level, the nanomaterial heat packing capacity is very high compared to normal material. But the costs are enormously high. Okay? So you have to think about all these properties, and then for sensors there is no go. You have to use nanomaterials or materials in the nano form. Next one. Previous one. Yeah, somebody had asked a question and nobody had answered. That is a precursor. You know, the chemicals are precursors. All chemicals are precursors. Whatever the chemistry you people do, the laboratory level, they're all precursors. But for an engineering application or product, those precursors are very, very specific. Some precursors are 2,000 rupees a liter. Some precursors are 50,000 a liter. Okay? That kind of a what you call price variation. Why? Because the impurities that has to left behind, if they have to be very, very small, the precursors have to become electronic grade. Okay? That means impurities are not accepted. Whereas in the structural grade, impurities are accepted. Very simple. Next one. So these are the phaser facilities. All of you would know the laboratory facilities are only a prototype generating. We develop a prototype, put it in a system and then prove it. That's it. Afterwards, in an assembly line, the production facilities are totally different because you require numbers in thousands, not in even tens. Okay? So this is all the equipment you require to do a nanomaterial synthesis. If I had time, I would have explained each of this equipment, why it is so unique, and some of them run into crores of rupees in each equipment. Okay? So only very good laboratories like National Physics Laboratory in Delhi, National Chemistry Lab, Chemistry Lab, NCL in Pune, things like that have all these facilities. Okay? But many of them are available only to the university toppers. Let me tell you, people might say, no, you are all allowed. No. You have to have academic excellence to enter into the top brand of even experimentation or even going to advanced countries on special scholarships. Okay? Next one. So this is another one we developed ourselves in DMSAT. This costed 20 crore rupees. That's why I wanted to show you the microwave CVD. You know, you get a material only 50 grams a batch. Okay? This is an experimental facility. So this requires top level, what do you call, conditions. Why it is so? Can anybody tell me? Why a simple looking reactor should cost you so much? Because the film, CVD is chemical vapor deposition. Somebody said, you know, atoms are deposited. From a chemical, you take atoms and then make it a film. To get a stoichiometric ratio, for example, NaCl has got 50% atomic percentage of sodium and 50 atomic percent of chlorine. To maintain that, not even 49.99, 50.001 is not acceptable. 01, sorry, is not acceptable. In that case, imagine, in 10,000 atoms of sodium, you have to get 10,000 atoms, not 9,099. Somebody can calculate. So that kind of a control is required to allow the gases inside so that you will get a particular sensorable grade nanomaterials. Okay? So that's why you require so much money to make a special reactors. These are all the properties of advanced countries. That's why they rule over us. It's not because Indians are inferior. We don't have facilities and money to do this. Okay? When you send your material or a system, they get evaluated by n number of countries. And if you don't do that, all your money goes into the drain. So you have to compete at the highest level in international level. Okay? That's where it's very important. Next one. So this is another important one. This is called a single wall CNT. This can make the surface conducting. For example, you put it on the earth, you can cover earth with 1 kilogram of this material. Entire earth can be covered by 1 kilogram. Okay? Single layered carbon nanotube. And what is the importance? Entire insulating surface will become conducting if the conductivity is maintained. No bond should be broken. It's like your LED bulbs. See in the room, a house, one bulb is broken, the rest of the thing is useless. Same. So to maintain the structural integrity is a question. But this is proven at a level even up to grams. If you get a kilogram, you can cover the entire earth. Imagine it's proven to 1 gram, you can cover entire state or a district, right? Still it is a challenge. We proved it only 1 feet by 1 feet and then extrapolate it saying that 1 gram will give. That's not the way, but it will happen. Next one. And many I have listed here, and this is only to tell you what is the importance of these materials, not to tell you the entire technologies. Previous slide. If I were to talk about this material properties, how these things are affecting in each of the structure, I require a lecture by itself. Okay? Some 40-50 slides I have to explain to you to understand what is the, difficult, intricate aspects of it. Okay? Next one. These are the one where DMSRD even collaborated with others to get into applications. This is also important. All of you people will be mostly working in the collaborators, industrial collaborators. You will not be working as the fundamental engineers or the scientists. Very few of them are there. In India, I can name over 100 scientists like Prasad Sata people, but thousands of them will help them. But they are also required. Okay? So this is where the collaborators are required to take care of several products and then do that. And even laboratories work as collaborators for others. One help the others. Next one. So these are all the different materials. These are materials only by taking their pictures at higher magnification gets you international awards. Some of them look like a beautiful flower, some of them look like a very good tile. Just by visually looking at this one, they say, oh, it's a unique picture, I'll give you an award. Many people get that awards. Next one. For example, this flower, you see that? Go to the previous one. This one, how beautiful it is. It is nothing but different particles have come into that shape, needle shapes. So that's why when Prasad said nano edge, I thought it could be this material. I said it could be nano. Okay, next one. So these are some of the chemicals, and all that you have to know is nanoparticles are nothing but 5 to 10 atomic layers. That means you have to be extremely careful about their reactivity. In fact, I worked on a committee where the toxicity of nanomaterials is of paramount importance. There was a national committee because everybody is doing bucket chemistry. Put a nanomaterial in a bucket, synthesize, it doesn't come in your laboratory result, you pour into the sink. That's not the way to do. Many people can get long-term health hazards if you do that kind of experiments. So I was in the national committee to tell about remedies. Okay? So those are also important. Especially the chemistry-based nanomaterial, that is a bottom-up approach, is very dangerous. Top-down like ball milling, the mechanical alloying, HEA, high entropy alloying, even heat generated, there is lots of heat-based, materials which will get, precipitate level, you differentiate the material. All those are much easier to contain, but the chemical routes are difficult to contain. Next one. Many of them got fantastic application. Go to the previous one. This application, solar energy conversion, nonlinear optics. These are the ones where, for example, solar energy. What is the efficiency of solar energy now? Can anybody tell? Louder. what is the efficiency? It is around 5 to 6%. Okay? And at best it can go to 21 to 22%. Okay? 22 to 23%, whatever the solar energy conversions are there, they are extremely costly. Whereas 10 to 11% is the 1/10 the price. Mostly our solar cells work at 10 to 15%. But the moment the rain is there, low intensity light is there, you have to go to only 2 to 3% energy efficiency. Otherwise the solution gives you 10, 15, 20% efficiency will not work at all. So it depends upon the range of temperature, rainy conditions, wind conditions. In that efficiency is low, but it still will work. So that is most important. Okay? That is called window of application. You have several parameters which have to work. The material solution or the device you give have to work in severe conditions. It's very important to know. Next one. So these are the ones which are required for automatic detections. Imagine some Naxalite or some terrorist comes to airport. You don't have to look at anything. Now ASS-based systems can scan the bag in no time. You don't require to go through the device to look at that. You can have a far-reaching device by temperature and chemical grasp. 1 in a billion capability is there. That means if your bag contains a different material compared to another one. For example, today I cooked a different food. I can make out, not by smell, by a long distance, what you call image process. And that image process, you can put in an AI system and say that, oh, today Ishwar Prasad has got a sandwich which is totally different compared to yesterday, or so far he has not brought that sandwich. I can make that announcement in the entire college. Okay, that is the technology has come. Next one. So these are the supercapacitors. Very, very important. You know, if you want to pack energy, capacitors are the best. Okay? Pack the energy for submarines, capacitors are required. Okay? And look at the percentage. That capacitors, unlike normal batteries, which will go for only 100, 200 cycles, the capacitor base can go into the thousands of cycles. That means you can use for a large number of dives into the sea. That is why they are very, very important. Next one. So this is a self-powered systems. That means the energy you store in terms of chemical enthalpy or even physical enthalpy, that is the heat content you give, can last for a number of cycles and give you the performance for a long time. Again, the insulation is most important, so that whenever we want to tap it, then only we tap the energy. Next one. So these are the ones which have gone on autonomous air underwater vehicles. These are the ones which are going to cost us billions of dollars if you have to put it in the entire Hindu Mahasagar, you know, the Indian Ocean. If you want to put a good surveillance, we don't have the systems. We have only model systems of 1 and 2. We need hundreds of them to cover the entire ocean. Even China doesn't have today, but tomorrow they're going to do because they have lots of money. So we have to fast move into this. Next one. This is another important one where a man can move by solar energy from here to Vizag on his own flight. It's called aerostat. Okay? The aerostats, that means a large balloon which is filled with hydrogen, you can only take off. Rest everything electronics will take care of it. Okay? And this has been devised by our laboratory. You can put an ink only on top. Lithography. You know, you only, just like ink printing in a printer, you can print it on a textile, but the textile is superb, you know. It doesn't even allow the hydrogen molecules to go out. Hydrogen atoms it will go out. Hydrogen atoms are much smaller in size compared to hydrogen molecules. So we have to ensure that hydrogen stays in the molecular form in the aerostat. Okay? But that also will take only from here to Vizag. If I want to go to Delhi, it's not available. Okay? Next one. So these are some things where the soldiers, I told you, no, the solar energy systems are prized systems for soldiers because they work in snow, ultra low temperatures, things like that. There from nature only they have to get the energy. They cannot carry the batteries, etc., etc. Even kerosene cannot be carried by soldier. Okay, all that they can carry a tent, erupted, the erupted team will come back to base, and then soldier will have to go every day and sit down in that. So if you know that defense systems, you will know how much we can advance in the 10 years in a country. Okay, next one. So these are the some 1,000 products I have put it in this what is called radars. Okay, and you have to work for 5, 10, 15 years. Every 2 years I change this slide. Okay, because some of them are realized, some of them are failed, some of them we import, things like that. Next one. So this is a next one, In 2020, we identified certain important systems. For example, the ID badges here. You people have got the ID badges, identification. You can have electronic identification. India did not have a single identification before Aadhaar came, right? All of you are only eye or, fingerprint identification. Now you don't require. You think that, this card of Aadhaar represents so and so. That itself is your signature. Okay? Next one. Then the third one. How much time I have? 10 minutes. Good time. Okay. There are no questions. Material properties as a fundamental property of physics. Next, electronics get generated and then show what is positive effect. That means you do a which are decreased to because any silicon just go to nano materials. No questions, 10 minutes is good enough. The questions even 10 hours is not enough. Next one is flexi electronics. I said in the beginning, India is poor in electronics. We don't have any assembly line. We don't have any chip in India, which is commercially made. Because any silicon wafer, which is a electronic grade silicon wafer, is 500 plus millimeter in diameter. That means half a meter diameter wafer, silicon wafer is required today for commercial. It is in millimeters, which is not enough. Okay? So next, go to next. Fold them like paper. Electronic system. The plastic will not break on which you have printed the electronic system. Lightweight, customized, strategic. These are all the costs will be tremendously different for different solutions. Okay? Then how do you do that? There are new materials, new technologies, fabrication. Even water, you can use it to get an electronic system. Change the purity, change the impurity. Okay, you can put impure elements in that and then make an electronic system. Then the defense applications are listed here. I will not talk about them because they are still evolving. Okay, nobody will tell you what they are doing in that. Next one. These are the challenges. This is important for you to recognize. In the next 10 years, India is going to make minimum 10 to 15 billion dollars import substitution in these systems. You will not be surprised your next door neighbor, instead of a solar cell assembly, you will have a flexi electronic system. Okay, that is the importance. Imagine that you can put one printed paper on your mobile and you will have your own applications, customized applications. Are possibility in abroad. They are happening now. By the time they come there, India should make a way. Okay, these are all most important. The last sentence is more important. Few or no commercial flexible electronic products are available in the market. In the beginning I wrote Indian market. Somebody asked me to remove that Indian. So I said in the market. It is understood is in the Indian market. Next one. So this is the growth rate. The data was available up to 2020 and in 2030 it will be 10 times more. Imagine this is a US dollar millions. 1,000 million is 1 billion. So that time itself it's a 1 billion. Now in the US market it is going to be 10 to 200 times the rate of increase because US doesn't supply or make for itself. It makes for the entire world. If India can take care of ourselves, we can save a lot of dollars. Next one. These are some of the devices. Some commercial people are doing it. Many of them you also might be using without knowing. Okay? Next one. So these are some thin battery films. That means you can have, earlier we used to have a calculator, which is called solar calculator, right? That was nothing but electronic one. Now that has gone off because the lithium battery use takes very small space and much better in, using that space in the calculator. Now calculator itself is not there. It is already come in the mobiles. Why do you require calculators? You don't. Next one. So these are the different, experimental techniques. They are not commercial techniques. That means you'll have to master them and do n number of experiments to put a analysis to see the best combination of processing conditions to get the products. So much research is required. Then afterwards you have to go to the industrial level and make the material. For example, I'll tell you, a fiber can be proven at micron level. That means you can make 100, 200 micron level fiber, which is proven. We can test micron level fibers. But if you want to test for tensile strength, minimum tensile strength, you have to get a millimeter to centimeter length. Okay? But a commercial length of fiber requires kilometers. One thread bundle is a kilometer level. The fibers are to be the commercial one in the kilometers. So the manufacturing technologies are totally different. Okay? So whatever we do, we deposit the material, make a thin film and spin it. That spinning can be even centrifugal spinning. Okay? So many techniques are there. We can do all of them. Next one. So these are the programs that I worked, in my 35 years. Each of the program is a few hundred crores. Okay? So this only will give us solutions. What level of laboratory experiments you do will not give a single solution which we can even tell internationally this will work. Okay? 10 of these programs are not able to give India a foothold of aero engine. That is the importance. Okay? So here I counted virtually the 40 major programs I worked on. 15 of them are functional and engineering material programs, functional materials. Rest of the 40, that is 25 number, slightly more, less than that, are the engineering materials. Imagine, these are the ones Indian defense itself has pursued to investing nothing less than 100 to 200 crores. Imagine you become a member of that. Your level of exposure will be that much higher. Okay? And you can contribute. That's what you should look for. Next one. So I was telling you, these two books are the latest in the international level. Okay? And they talk about all those things which are required for functional and engineering materials at one place in the entire world. Okay? Most of the authors are from our own laboratory, but we took the literature or results published by best in the world. So if you read that one, good enough, but they are very costly. Each book is 10,000 rupees. Okay? So you can download them after some time when Springer gives it for free of cost. Okay? Some of the other materials are given in the other books. These two books are the Guinness records because they've been free download. Sometime in the COVID time I gave free download for my books. So more than 1 lakh people downloaded the books. That's a Guinness record. So you can take the data or the material information, but how much you want to use it. Otherwise it's like a story book. You say a nice movie or a good book you read and then forget about it. Some of them will become your career options. I'll be happy if somebody develops a career on a particular material, go and produce even a single product. For example, Jamshedpur, one fellow, made an industry of the high sulfur containing rubber, which is very elastic, and he is supplying abroad now, making thousands of dollars every day as a profit. So that is what is most important. So what I talked so far is science, engineering, technology perspectives, while engineering materials provide sustenance. Engineering materials give only sustenance. You can sustain the society. And the value of the society comes from the functional materials. Some unique functionality or unique materials you have to do, then only society gets better benefited and will become #1 in the world. Okay? Several advanced materials require 360-degree solution. It's called all-round solution. That means right from raw material to synthesis, production, testing, making products and prototypes, putting in systems, using the systems, getting the field data, analyze them, then improve the lifing. The life of the system is improved. Many aircrafts are under life extension. Indian aircraft is supposed to work only for 20 years, but we have some aircraft that are flying even 30 years. Okay? We can do that. All those things are required, and that will be done only if you have the basic fundamental information and knowledge about the entire material, including 3D printing now. Okay? So, India has a long way to go. Sky is the limit. Don't think that sky means Suresh Kumar Yadav. So what is that, Yadav? There is not an abbreviation. Sky means real sky. Sky is the limit means you can achieve anything if you work focused. Okay, with a goal in mind. Under Indian material community, and it's a vast community, let me tell you. Professionally, there are 20,000 material scientists in India. That is one laboratory scientist in China. Why do you think that China has made so much progress? One laboratory, rare earths laboratory in China is 20,000 scientists. Because they supply for 90% of world rare earth requirement from China itself. Okay? That is the kind of money they have. So, India, to do India totally self-reliant, that means we can sustain or live on our own. We cannot today. Nobody can live in any part of the world on himself. Maybe US might, I don't know. China might, I don't know. Russia might, I don't know. But apart from these countries, even Japan, Germany, UK, they cannot live on their own. Leave out India. Okay? We are so dependent on so many other things. Okay? And then we require an ecosystem. What is an ecosystem? Today I want this, tomorrow you can get it. Can you get it in India? You want a laptop, Surface Pro. You have to order and wait for 3 months. Right? So that is not advanced country. Ecosystem is not only that. You want to make a Surface Pro in India, you should be able to make. Provided I give you, say, 100 crores as a financer. Some industry should come forward and make, 10 lakh numbers of computers, laptops. A state government can order, but do you have the capability? We don't have. That is what is required in the, what you call as a ecosystem. That only will make our Indian exports 10 times. Without 10 times our exports, our import-export, what you call the gap, cannot be even narrowed. Leave out, making it zero. We import so much, our exports, we talk, little export, we'll say, oh, we have done this. No. We have to do, that's why I ask, whenever somebody says, there is a Manmohan Singh attitude, there is a Modi attitude. Modi was counting when COVID, vaccination is given. Oh, we did 10,000, 1 lakh, things like that. Manmohan Singh only asked, how much percentage of the population? It is not by 1 decimal. Then he said, oh, you require 3 years to do the entire vaccination of the country. Then only Modi realized. He did not know. Prime Minister realized. Then he asked, what to do? Arey, aap bhi ek tika laga dijiye. So he had put a vaccination to his own shoulder. Next day, the 10,000 number has gone 1 lakh a day. Then later it's become 10 lakh a day. Right? We require always that kind of mass mentality in India. Some big fellow, Amitabh Bachchan has acted, that means everybody will make Amitabh Bachchan a hairstyle. Right? So Indian mentality is like that. We are mostly followers. We require leaders. Okay? Not huge numbers like America. America, 10 people, there is a leader. We don't require. We require only at least for 10,000 people, 1 leader. Okay? We don't have now. Okay? That is what is called ecosystem. So I thought I covered what this kind of an international seminar is supposed to do. They are supposed to tell you what all I covered in this lecture as a canvas. Each stroke of the brush. I made a beautiful picture. You look at the picture, you feel, oh, today I've seen a good picture and came back. It is like, any picture you see in the theater. No, you should become a director of the movie. Look at it, how each scene is made, how each actor has acted, how the cameraman captured each of it. Then learn at least 1 10-second making of the movie by by yourself. Then you will understand a big picture of making the entire canvas. The pictures by great people will not be made in a day. They take 2-3 years to make the picture. Okay? We should also do that. Indian build-up will happen in a slow process, but a steady growth. All the best and be the change makers. Good.
Thank you, sir. Now we will have a wonderful lecture.
You have a water bottle?
You are all enlightened. So what is how advancement of our country, especially DRDO, is doing such wonders of creating nanomaterials. Sir said in future you may see you can fly from Vijayawada to Vizag. Okay? Yes, all this can be happen because of these nanomaterials. Okay? So you people like the chemistry and the electronic peoples, you can do certainly wonders.
Better faculty to summarize. What I want to say is, anybody can summarize what we have spoken. You know, it's up to the student takes as a career. You people have to take a career. These are all the parts and parcel of a national or international seminar. Somebody has to give it. Somebody will say, no, this fellow has talked like what he's telling. Even a reporter will write. That's not important. What is important is, out of the 200 people, I always look for one chap which writes to me, sir, I want to work in this area. Who are the best people in the world to work? If I have to make inroads in India, who will do that? Help me. You know, that's all is required. Rest everything, I've already delivered 500 talks, conducted 150 seminars. So, that and all only at my contribution for the country. Rest everything I sit down in my, scientist chair or laboratory director chair, I will do anything that other directors will do. So that's not great. Okay?
Thank you, sir. Same thing we also expecting from the students.
Sure. Do that.
Listening is not very important, but involving and inspiring is very most important. At least like the scientists, future scientists will be very happy. So thank you, sir. And we are running short again. As per sir said, I don't want to repeat again. Okay. So you have half an hour time for a lunch.
No, give them 45 minutes. I pay 15 minutes loss and let them pay 15 minutes loss.
Sir, yeah. International talk is going to start at 1:30. So please, for this today, excuse me and have a lunch within 30 minutes and please be joined sharply by 1:30 here.
Okay? All the best. Take care.
Thank you very much. Mami, tokens and madam garu istunnattunnaru.